Welcome back to another video. Today we'll take a look at the application of Euclidean algorithm. And one of the applications is to find the Bessel identities, which state that the greatest common divisors of A and B can be written as the linear sum of original two numbers A and B. Another word, you can find x and y, integers x and y, such that the greatest common divisor of a and b is ax plus by. So here is the statement of Bessel identity, which is in theorem 2.5.2. So let a and b be integers such that a is not 0 or b is not 0. If D is the greatest common divisor of A and B, they will be x and y, which are integers, such that D equal to ax plus by. Okay, this one is a theorem in section 2.4. We've learned that there exists x and y. There exists integer x and y such that the greatest common divisor of a and b is ax plus by. Actually, this is the Bessel identity. We can use the Euclidean algorithm to find such integer x and y. So let's take a look at the Euclidean algorithm. This one here. So if you try to find the greatest common divisor of A and B, you have to divide one of the number so that you can have the division algorithm like this. And hence you gotta have the list of these equations, right? You might begin y divide b by a, and then you have remainder of r1. And the remainder of r1 must be less than a. And the next thing you have to do is to divide a by the remainder of a. Then you have the new remainder, which is r2, right? And you divide divisor r1 by the new remainder r2 so that you have this equation. And then try to do it all the way to the last one. And the last equation means that when you use the divisor to divide the previous divisor, the preceding divisor, okay? And then we don't have remainder. That means that the greatest common divisor of A and B is just Rn. Okay, this is Euclidean algorithm. But how to find x and y such that ax plus by equal the greatest common divisor of a and b. So the first thing to do is to take a look at this equation, which is the equation that is next to the last one, which is next to last equation. Start with this one. So let me write this. So we write this one. So we're gonna have Rn minus 2 equal Rn minus 1 and Qn minus 1 plus Rn minus 1. Sorry, just Rn. And you need to, we try to write Rn, right? Because Rn is the greatest common divisor of A and B. We try to write it into this form ax plus by, where x and y are integers. So we gotta write this equation Rn equal to Rn minus 2 minus Rn minus 1 Q1n minus 1. So that's what we have right here. And then what next? The next thing we are going to do is to try to rewrite Rn from these equations. Okay, the next equation here. So we gotta have Rn equal Rn minus 2 minus, so what is Rn minus 1 is become Rn minus 3 minus Rn minus 2 Qn minus 1. Okay, Qn minus 1. So I think I write this one wrong here, right? So this must be just Qn. Okay, so this must be just Qn. Then try to rewrite Rn in terms of Rn minus 2 and Rn minus 3. Then what do we have next? We gotta have, okay, let's rewrite it. Rn minus 2 plus Rn minus 2 Qn minus 1 Qn minus Rn minus 3 Qn. Okay, then what do we have next? Oh, this must be minus. Okay, correct. Then what next? The next thing we're going to do is to rewrite Rn minus 2 times 1 plus Qn minus 1 Qn. And what happened to this term right here? So we gotta have just plus Rn minus 3 minus Qn. Okay, next let's rewrite R2. Okay, Rn2 from this equation. So we move this term right here to be the left side. So we gotta have Rn minus 4 minus Rn minus 3 Qn minus 2 times 1 plus Qn minus 1 Qn plus n3, right? Rn3 minus Qn. Then what do we have? We distribute this term into Rn minus 4 and Rn minus 3. So we gotta have Rn minus 4. Then what next? We gotta have 1 times or 1 plus Qn minus 1 Qn. And minus Qn minus 3 Qn minus 2. 1 plus n minus 1 Qn. And minus Qn, 3 n minus 3 Qn. And we factorize Rn minus 3. Then what do we have? We could have Rn minus 4 times 1 plus Qn minus 1 Qn. And we write and we factorize Rn minus 3, right? We could have Rn minus 3. Then what next? We gotta have, so I think this term turns out to be minus, right? So we're gonna have minus Qn minus 2 minus, okay, Qn minus 2 n minus 1 Qn and minus Qn. Factorize Rn minus 3 and continue to do it so that you're gonna have Rn minus 5, Rn minus 4, right? Okay, and you're gonna have this remainder, and this remainder is multiplied by these two integers. Okay, with this pattern, this is an integer and this is also an integer. So I gotta rewrite like this. So now, so if you write it to, let's say you end up with, okay, this is Rn, right? Let's say you try to rewrite the remainder so that this one become R2 and this one become R1. Okay, sorry, this one become R1 and this one become R2. So we're gonna have R1 L. I gotta just write L1 plus R2 L. Okay, where L1 and L2 are just integers. And we try to rewrite R1 in terms of A and B. So we just try to have Rn in terms of A and B. So let's take a look at this equation here. Right here. Oh, sorry. This one here. And let's rewrite somewhere here. Okay. Okay, let's go to up here. Right here. And substitute R1 by this and R2 by this one. So let me substitute R2 first. So we're gonna have R1 L1 plus A minus R1 Q2 L2. Okay. And then we're gonna have R1 right here. So we're gonna have R1 L1 plus A L2 minus R1 L2 Q2. Then we're gonna have R1 L1 minus L2 Q2 plus AL2. Okay. Then what do we have? We substitute R1 by this equation. So we're gonna have B minus AQ1, L1 minus L2 Q2 plus AQ2. And distribute this term so that we're gonna have BL1 minus L2 Q2 minus AQ1 L1 minus L2 Q2 plus AQL2. Okay, and rewrite this term. So we're gonna have AL2 minus, right? Minus which one? Minus Q1 L1. Okay, Q1 L1 and plus Q1 L2 Q2. Okay, and plus B times L1 minus L2 Q2. So you need to substitute this remainder. Okay, substitute this remainder by preceding remainder until you have A and B, so that you can have the greatest common divisor, which is Rn, right? This one here. And Rn becomes A times this integer, okay, plus B times this integer, okay. So this term right here look like the Bessel identity, okay. So this is how to write Bessel identity by using Euclidean algorithm. And that's it for this video.